So tonight for our Unit 5, our final live chat in the class, we're going to talk about some variations in database systems. We'll touch on data warehouses and data marts, distributed database systems, some online analytical processing, and talk about data mining a little bit. Because a few of those items are in your Unit 5 IP that's due on Sunday. Note that for the IP5, it has two sections to it. The first section is your normal word paper where you have to answer some questions, right, and provide some information. And then the second part is a PowerPoint presentation. I don't make you do the PowerPoint, so you can skip that part two of the IP5. It's very confusing, and a lot of students struggle with that part, and I'd rather you focus your efforts on ensuring you complete the entire Word document portion. IP5 is a very large portion of your final grade. It's weighted very heavily and it's worth 250 points. So make sure that you get that completed and turned in on time on Sunday, because there is no extensions for Unit 5 IP. It's due when it's due. Class ends that following Monday. A Monday the class ends and I have to turn in final grade, so I can't accept anything past that. So make sure you do what you can to get that IP5 submitted. That being said, we'll talk about some distributed database management system issues and concerns, and then what exactly a distributed database is. A distributed transaction management system is one that accesses data which is stored at more than one location. So you could have, for larger companies, probably it's more pertinent than it is for maybe a small retail store like we have. But in the event that maybe you have 6 of these stores and they're in different parts of the country, you could have a distributed database that collects data from all of those different locations and shares data with all those different locations. And that would be a distributed database. The transactions for those are divided into several sub-transactions. There's one for each site, which has to be accessed, represented by a system agent or an agent. So therefore, the distributed database management system must ensure that synchronization of those sub-transactions with other local transactions executing concurrently at a site, and that the synchronization of those sub-transactions with any global transactions, which may be running simultaneously at the same or different sites, is they have that ability to do that. The global transaction manager acts as a transaction coordinator. It is present at every site. It helps coordinate global and local transactions which might be initiated at that specific site. DDBMS is highly dependent on your ability of all your sites to be able to communicate reliably. So any communication failure can result in network becoming split into 2 or more partitions, and then it may be difficult to distinguish whether there is a communication link or if the actual site itself has failed. A distributed database system uses global database names, which is a unique name given to each distributed database. It's formed by prefixing the database's network domain name with the local database name. It follows a standard internet conventions with levels separated by dots, ordered from leaf to root, left to right. So this is an example of a distributed database might look like. Notice we have our .com at the top, our north, west, and south sections. Then we have cities within those sections. And then finally, we have databases that are in each of these different locations. So to reference a database, you start with the name of the database, right? Sales, then they remember it's separated by dots, ordered from leaf to root, left to right. So here's your leaf. This is our root. So sales.aberdeen.north.com would be the database name for this sales database at this location. Rentals.glasgow.north.com would be the name of the database to access data at that location. And you have to use the fully qualified name to access data in a distributed database network. It has different types of transactions that can be completed at each. They are remote SQL statements, which is a remote query, which selects data from one or more remote tables, all of which reside at the same remote node. Remote update modifies data in one or more of those tables, all of which are located at the same remote node. You can have distributed SQL statements, which is simply a distributed query, retrieves data from 2 or more nodes. Distributed update modifies data at 1 or 2 or more of those nodes. A remote transaction contains one or more remote statements, all of which reference a single remote node. So it wouldn't be from your local database. It'd be at one of those those further ones like the sales, right? And then a distributed transaction which includes one or more statements that individually or as a group update data on two or more of those distinct nodes of a distributed database. Oracle ensures integrity of these distributed transactions using what is called two-phase control. So that's distributed databases. I know in your IP5, you have to indicate what steps you would need to take in order for your database to become a distributed database. So just think about what a distributed database is and what steps you would need to perform for your single database, right, to make it match that specific setup and layout. Data warehousing is another area, which we'll talk about now, which in your IP, you have to discuss what steps you would need to take or modifications you would need to make to your little database that you have now in order for it to become a data mart or a data warehouse. So we'll talk about what those are so you have an idea of what type of information you'll want to provide. Designing a data warehouse. To begin a data warehouse project, you have to find some answers to such questions such as which user requirements are the most important, which data should be considered first. Should the project be scaled down to something more manageable? Because a data warehouse project is quite large. It can consume a very long period of time, years, in fact, if you're going to try to design the whole data warehouse in one project. For many enterprises, the way to avoid these complexities associated with designing a data warehouse is to start by designing or building one or more data marts. A data mart allows your designer to build something that is far simpler and achievable for a specific set group of users, right? Because fewer designers are willing to commit to an enterprise-wide design, which has to meet all the user requirements at one time. So despite this interim solution to building a data mart, the goal is the same, the end creation of an enterprise-wide data warehouse. Your requirements collection and gathering analysis stage of a data warehouse project involves interviewing appropriate members of staff, like marketing users, finance users, and sales users, to help enable the identification of prioritized set of requirements that your data warehouse has to meet. But at the same time, interviews are conducted with members of staff responsible for those operational systems so that you can help identify which data sources have very clean, valid, and consistent data, which will remain supported over the next few years. Because your data mart essentially is or data warehouse is just what it says. It's a warehouse of all of the data within your organization. So you're going to pull data from any legacy data systems or any current relational databases you might have and build a data warehouse from all of that data. Historically, the data in the data warehouse is unchanging. It gives a picture of past performance for your organization. So, and it helps provide you with reporting abilities and capabilities so you can make sound business decisions for the business of your future business of your company. These interviews provide necessary information for a top-down view, which is user requirements view, and the bottom-up view, which is data sources view of the data warehouse. The database component of a data warehouse is described using a technology which is called dimensionality modeling. We'll talk about that a little bit. Two main methodologies incorporated the development of an enterprise data warehouse, or EDW, and those are proposed by two key players in this data warehouse space. Kimball's Business Dimensional Lifecycle, presented by Kimball in 2008, and Inman's Corporate Information Factory, CIF methodology, which was presented by Inman in 2001. They're still very relevant technologies and theories, and they're still used today when developing data warehouses as a base to start with. This little slide shows data warehouse development methodologies, what their main advantage and main disadvantages of each of the different methodologies. For Inman, it has a potential to provide a consistent, comprehensive view of your data, but its disadvantage, it's a very large, complex project that may fail to deliver value within a allotted time period or budget. Kimball, on the other hand, is a scaled down project that gives you the ability to demonstrate value in a more achievable within an allotted time period. A main disadvantage of that, of course, is that the data marts can potentially be developed in sequence by different development teams using different systems. The ultimate goal of providing a consistent and comprehensive view of corporate data may never be easily achieved. So when you're building this data warehouse, you want to make sure that you have a dedicated team of professionals in your organization that will be there consistently to build all the data marts using the same process that they used to build the first one. Right? You want it to be very consistent so you don't have this issue of using different systems, which will then ultimately not allow you to get to the point of having your enterprise data warehouse like you think you need. So Kimball is the business dimensional lifecycle. Ralph Kimball is his name. He's a key player in the space. He is about the creation of an infrastructure capable of supporting all the information needs for your enterprise, uses new methods and techniques in the development of the enterprise data warehouse. The first data mart. So Kimball builds data marts, right? Several data marts are built together, and when they are incorporated into the same structure, they now become your data warehouse. But so you pick a functional area in your organization that you want to focus on to build your first data mart. It's critical in setting the scene for later integration of other data marts as they come online, because lessons learned from the first build you apply to your second, and then you use that same process. You just apply your lessons learned as you go, and then as you move along through the different functional areas in your organization, the time frames should be able to be shortened, because now you've been working it for a while, right? You know the process. It becomes, you get into a rhythm and your flow, and then it makes it a lot easier. The integration of these data marts ultimately leads to this development of the enterprise data warehouse, as I mentioned. It uses dimensionality modeling to establish the data model, which is called a star schema for each data mart. The guiding principle here for this life cycle is to meet the information requirements of your enterprise by building a very single, integrated, easy to use, high performance information infrastructure, which can be delivered within a 6 to 12 month time frame, right? And that's just one data mart, 6 to 12 months. So you can imagine if you have a very large organization with lots of data, it could take several years you to get to your ultimate goal of realizing an enterprise data warehouse. The goal is to deliver the entire solution, right, including the data warehouse, for ad hoc tools, reporting applications, advanced analytics, and any necessary training and support for the users that are going to be using the data warehouse. His life cycle has three main tracks. There's a technology track, which is the top track. The middle track is data, and the bottom track is business intelligence applications. It uses incremental and iterative approach that involves the development of data marts that are eventually integrated into that enterprise data warehouse. This gives you an example of those three tracks and how the project may be laid out, right? Starts with project planning. You have your business requirements definition section, which covers all three tracks. And then you have your top track, your technical, your data, and your BI application at the bottom. They all are ultimately managed by project management office, usually at your organization. And then they fall at the end, they go to the maintenance and growth phase, which then repeats this cycle if there's any maintenance required, right? So this is a never ending process. And then as you develop all of your different data marts, you're doing the same process for each of those. This dimensionality modeling is a logical design technique which aims to present data in a standard iterative form that allows for high performance access. So eventually every dimensional model, or DM, is composed of one table with a composite primary key, which is called the fact table, and it has a set of smaller tables which are called dimension tables. So it's a little bit different than a relational database structure that we built, right? Every dimension table has a simple non-composite primary key, which corresponds exactly to one of the components of the composite key in that fact table. I'll show you what this looks like. It forms a star-like structure, which is why it's called a star schema or a star join. So all natural keys, meaning the keys that are with the original source data, are replaced with surrogate keys, meaning that every join between the fact and dimension table is based on the surrogate keys, not on those natural keys that were present in the data to begin with. The surrogate keys allows the data in the warehouse to have some independence from the data used and produced by the online transaction processing systems, or OLTP. A star schema is a logical structure, has a fact table containing your factual data in the center, which is then surrounded by denormalized dimension tables containing reference data. So in our database, we created a relational database. We normalized the data, right? With this is totally opposite of that. It uses denormalized data in these dimension tables. The facts are generated by events which occurred in the past, which is why you use all your source database systems to feed your historical old data into, right? So that it can generate and build these fact tables based on all of that data. The data is therefore unlikely to change regardless of how they're analyzed. So the data is more for historical purposes and used for business processes and business decision making. The bulk of the data is in fact tables, which can be extremely large. It's important to treat this fact data as a read-only reference that will not change over time. And more useful fact tables contain one or more numerical measures or facts that occur for each record and are numeric and additive. So the fact table has a lot of keys in it to join back to those dimension tables. And then anything else you see in that table, if it's not a key field, it's going to be numeric and additive. Dimension tables usually contain descriptive textual information. Dimension table attributes are used as the constraints in data warehouse queries. Your star schema can be used to speed up the query performance by denormalizing reference information into a single dimension table. There's a variant of the star. It's called snowflake schema. It has a fact table in the center and it's surrounded by normalized dimension tables. And the starflake schema is a hybrid approach that contains a mixture of star, denormalized, and snowflake normalized dimension tables. So this is a dimension and fact table example. So you can see our fact table has a lot of keys in there, right? FK, foreign keys, a whole bunch of foreign keys, and then everything else that's in this table is numeric and can be additive. So offer price, selling price, commission, and revenue. And then attached to that table, we have all these dimension tables, which again has all the keys, has some keys in it. So you join back to your fact table, and the data in there is more descriptive. It kind of gives you the history and the guts behind what's in that actual fact table. This modeling is predictable and standard form of underlying dimension model offers some important advantages. It provides very efficient processes, ability to handle changing requirements, extensibility, ability to model some common business situations in the querying process, right? And it also gives you a predictable query processing model that you can use across all your different data marts and eventually your data warehouse. It begins by defining that high-level dimension model, which progressively gains more detail, is achieved using a two-phased approach. The first phase is a creation of the high-level dimension model, and then the second phase involves adding detail to that model through the identification of different dimensional attributes for that model. So here's phase one, right? Involves creation of a high-level dimension model using this four-step process, where we select the business process, we declare the grain of the process, we choose our dimensions, and then we identify the facts that are associated with that dimension. This is an example of what a star schema might look like for, let's say, a data mart. Notice we have our fact tables in the darker, whatever color that is, the darker color. The ones in the middle of the lighter shade, those are some conformed dimension tables, and we'll explain what that is, I believe, in the next slide. And then we have our dimension tables outside, which join to your fact tables. Again, there's our fact tables. They have a bunch of keys in it, and then data, which is numeric or additive. Some additional design issues with the data mart. Duration measures how far back in time the fact table goes. So therefore, a very large fact table can raise at least two very significant data warehouse design issues. It's often difficult to source increasingly old data. Depending on how many old data sources you have, you might have trouble sourcing that data. And it's mandatory that the old version of the important dimensions be used, not the most current, which is known as the slowly changing dimension problem. This means that the proper description of the old dimension data must be used with the old fact data. So often a generalized key has to be assigned to important dimensions in order to distinguish multiple snapshots. This lifecycle produces a data mart that supports your requirements of your particular business process, right? So sales, marketing, or production, whatever other departments you might have in your enterprise. You break those down and each of them would have their own data mart. Finance, right? So a dimension model, which contains more than one fact table sharing one or more conformed dimension tables, is referred to as a fact constellation. So those conformed dimension tables are shared across different fact tables. Some development issues when designing a data warehouse, using selection of which development methodology you're going to use, right? So you have to decide if you're going to use Inmon or Kimball. The identification of key decision makers in your organization to be support and how you're going to support their analytical requirements. The identification of data sources and assessing the quality of the data that's in those data sources. Selection of an ETL tool, that's extract, transform, and load tool for loading, used with data warehouses to extract data from your sources. right? Transforming that data, cleaning it up, getting rid of any anomalies there may be in the data, and then finally loading that data into your data warehouse tables. And then identifying the strategy for any metadata, how that's going to be managed. There's a few other issues listed here as well. Um, Establishing storage capacity requirements for the data warehouse, right? You're going to have to try to calculate how much space on your network or how much space you're going to need to actually store all of this data. Right? It's going to be quite a bit of data, especially if you're doing it for your entire organization. Establishing an appropriate architecture for the data warehouse or data mart, and then dealing with any organizational, culture, and political issues associated with data ownership. Some functional areas may be reluctant to release control of their data that they might have in their data warehouse. So those kind of issues do come up, and they need to be addressed by your senior management team. Okay, so now we'll touch on online analytical processing, or OLAP transparencies, and we'll talk about what those are. So they're part of the business intelligence technology. So accompanying the growth in data warehousing is an ever-increasing demand for users for more powerful access tools that help provide them with some advanced analytical capabilities. Two main types of access tools are available, namely online analytical processing, OLAP, and then data mining tools. OLAP and data mining differ in what they offer the user because of that, they're complementary technologies. An environment that includes a data warehouse, or more commonly one or more data marts together with tools such as OLAP and or data mining, are collectively referred to as what is called business intelligence technologies. And you have to address that in your IP. You have to talk about business intelligence, BI technologies that would be available for you. So just keep that in mind as you're working on your paper. Online analytical processing, the original definition for that is the dynamic synthesis, analysis, and consolidation of large volumes of multidimensional data, which was presented by Codd in 1993. It simply describes a technology that is designed to optimize the storing and querying of large volumes of multidimensional data, excuse me, which is aggregated or summarized to various levels of detail and support that analysis of that data. It enables users to gain a deeper understanding and knowledge about various aspects of your corporate data through very fast, consistent, and interactive access to a wide variety of possible views. It allows users to also view corporate data in such a way that it is a better model for the true dimensionality of your enterprise overall. It can help easily answer some questions like who and what. However, the ability to answer the why type questions, which is what distinguishes OLAP from general purpose query tools. Types of analysis range from basic navigation and browsing, which is called slicing and dicing, to calculations, to more complex analysis, such as doing time series and complex modeling. BI is a very strong tool to use, and it's used a lot with data warehouses. These are just some examples of some different OLAP applications and maybe these different functional areas, what they would do. Finance may do budgeting or activity-based costing. Sales would do sales analysis and sales forecasting. Manufacturing would probably do production planning and defect analysis. And then, of course, marketing does market research analysis and sales forecasting, and maybe some promotions analysis as well. Although these applications are found in widely divergent functional areas, they all have the same following key features. One, they provide multidimensional views of your data. They support complex calculations, and they also provide time intelligence. A core requirement of building a realistic business model. It provides basis for analytical processing through a very flexible access to your corporate data, and the underlying database design that provides the multidimensional view of data should treat all the dimensions equally. Time intelligence. So here is a good one. This is a key feature of almost any analytical application. Such a performance is almost judged always over time, right? Day, month, year, quarter, century, whatever. Time hierarchy is not always used in the same manner as other hierarchies. Concepts such as year to date and period over period comparisons should be easily defined. So that's what these tools allow you to do. A multidimensional data is facts, which is numeric. such as property sales revenue data and the association of this data with dimensions such as location of the property and time of the property sale. So which is the best representation of multidimensional data? Relational table, a matrix, or a data cube? We consider the data cube to be a solid 3D structure with equal sides. However, an OLAP cube is an n-dimensional structure which sides that need not be equal. Alternative representations for n-dimensional data is to consider a data cube as a lattice of cuboids. Each cuboid represents a subset of any given dimension. OLAP operations that you can perform on these data cubes includes doing roll-ups or drill downs or slice and dice and pivot of your data. And we did a pivot table in our IP3. It was called crosstab. That crosstab query was a sort of pivot table where you changed how the data is presented. So that this is very easy to do using OLAP and a data cube. Here I explain each of the different OLAP operations. What they do: roll-up performs aggregations on the data by moving up the dimensional hierarchy or by dimensional reduction. A drill down is a reverse of a roll-up. It's revealing the detailed data that forms the aggregated data. Slice and dice gives you the ability to look at data from different viewpoints, right? The slice operation performs a selection on one dimension of the data where dice uses two or more. And then a pivot is ability to rotate the data to provide an alternative view of the same data. For example, sales revenue data displayed using the location city as your x-axis against time quarter as the y-axis can be then rotated so that time is the x and location city is the y. There are many variants, varieties of different OLAP tools available. The choice has resulted in some confusion, with much debate regarding what OLAP actually means to a potential buyer, and in particular, what are the available architectures for OLAP tools. So different categories of OLAP tools. They're categorized according to the architecture, which is used to store and process this multidimensional data. And we'll talk about, there's actually a fourth one. The three main ones are multidimensional OLAP, relational and hybrid, and then there's a desktop OLAP, which I added in at the end. We'll talk about each of these three different categories in the next few slides. So a multidimensional OLAP or MOLAP uses a very specialized data structure and multidimensional database management system to help organize, navigate, and analyze the data. It's typically aggregated and stored according to predicted usage to enhance query performance. It uses an array technology and efficient storage techniques, which minimize the disk space requirements through very sparse data management, and also provides excellent performance when the data is used as designed. It traditionally requires a type coupling with the application layer. Recent trends segregate the OLAP data from the data structure through the use of published application programming interfaces. This is what a typical architecture of a data architecture for the MOLAP may look like. So you notice in the center, there's a MOLAP server, right? We have a database, relational database server or legacy system on the left-hand side where we're loading data into this MOLAP server, which handles all the data requests and result sets back to the end user access tools. So there's that middle server in the middle, which is very complicated and very complex to operate and set up. The underlying data structures are limited in their ability to support multiple subject areas and provide access. Navigation and analysis of the data is limited because the data is designed according to previously determined requirements. Requires a very different set of skills and tools to build and maintain that database, thus increasing the cost and complexity of your support. ROLAP is the fastest growing style of OLAP technology due to the requirements to analyze ever increasing amounts of data. It supports relational database management products using a metadata layer. It avoids the need to create a static multidimensional data structure like we did for MOLAP. To improve performance, some products can use SQL engines to support the complexity of this multidimensional analysis, while others recommend or require the use of highly denormalized database designs such as the star schema. So you'll see in this instance, we have a ROLAP server in the middle, but there's no data stored on the ROLAP server. It just helps handle the processing of requests through SQL to the relational database server, which then returns the result set through the ROLAP server to the result set to the end user. It's very simple to set up, and a little bit more cost effective. Performance problems associated with parsing complex queries require multiple passes through your relational data. So it makes them a little bit, you may have to take several passes right through the rollup server to get what you're looking for, given the complexity of those queries, querying against that data. And then of course there's hybrid, which you could imagine. A hybrid would be a conglomeration of both the rollup and the molap. So it uses both. It does have a molap server, which for some part we can load some data to the molap, data request and result set from the end user tools, go through that server, or we can just use the rollup function where we send the SQL code directly to the database server and get the results set back. So it has the both of those in there, and you get the best of both worlds using a hybrid approach. This architecture results in significant data redundancy and may cause problems for networks that support many users. Only a limited amount of data can be effectively maintained. So that's something to keep in mind. There's some development issues with this process. And then we finally have our desktop OLAP, where we store the OLAP data in client-based files and support multidimensional processing using your client multidimensional engine. That requires relatively small extracts of data be held on the client machine. So they download data onto their machine, possibly through the web, but it makes processing of the data a little bit faster because you're doing it locally on your machine. So now we'll touch on some data mining transparencies. Data mining is simply the process of extracting valid, previously unknown, comprehensible, and actionable information from large data sets and using it to make critical business decisions. Involves the analysis of that data, use of software techniques for finding hidden and unexpected patterns, reveals information which is hidden and unexpected, as little value in finding patterns and relationships that are already intuitive, right? These patterns and relationships are identified by examining the underlying rules and features in the data. Tends to work from the data up, and most accurate results normally require very large volumes of data to deliver reliable conclusions. So the more data you have, the more effective this process is going to be. Some examples of applications of data mining, there's just a few listed here, right? Retail marketing use data mining to identify buying patterns. Banking may use it to identify loyal customers or predict customers likely to change their credit card affiliation or determining credit card spending by customer groups. So having all, and you can imagine the amount of data these sort of organizations may capture. Insurance companies use it for claims analysis, predicting which customers will buy new policies. Medicine, we use it for identifying successful medical therapies for different illnesses, or to predict future healthcare costs is what they use data warehousing for, and predictive analysis, predictive modeling. We can do database segmentation, link analysis, or deviation detection. There are recognized associations between these applications and the corresponding operations. So for example, a direct marketing strategy may use database segmentation. It might not use link analysis or predictive modeling in that example. Techniques are specific implementations of the data mining operation. Every operation has its own strengths and weaknesses. Selection of the tool. You want to make sure that the tool is suitable for certain input data types, the transparency of the mining output, any tolerance of missing variables, the level of accuracy, and the ability to handle very large volumes of data, because you're processing data mining, you're doing data mining in a data warehouse environment, which inherently has a very large amount of data. Data mining and data warehousing. The major challenge here is to exploit data mining is identifying suitable data to mine. That's why data mining requires single, separate, clean, integrated, and self-consistent sources of data, which is what a data house is well equipped to provide. Data quality and consistency is a prerequisite for mining to ensure the accuracy of any predictive model. So you have to make sure that data is clean. You don't have, that's why during that ETL process, right, the extract, transform, and load, the transform process is going to clean the data, make sure it's very clean, get rid of any anomalies, and load that very clean data into your data warehouse. And then it's important to continue doing that process when you're loading more data, to keep it clean as possible so that you can do some very effective predictive modeling. It's advantageous to mine data from multiple sources to discover as many interrelationships as possible. And then, of course, the data warehouse does contain data from a different number of sources. That's why it's suitable for doing data mining in. The results of a data mining study are useful if there is some way to future investigate the uncovered patterns. So data warehouse provide the capability to go back to the data source because that data is always going to be there. That's the live chat portion. We'll talk about the individual project. As I noted at the start of the live chat, there are no extensions granted on this project unless you have an incomplete in the class. If you have incomplete, you have 5 days from the end of class to complete any missing assignments that you need to turn in. If you don't have an incomplete, you need to have the paper turned in by Sunday evening. Class ends on Monday. Again, you don't have to do part 2 of this project. It has 2 parts. The part 1 is the Word document that you've been creating since the start of class. And part 2 is a PowerPoint presentation, which I don't make you do that portion because I'd rather you function or focus on the paper itself. There's a lot of information in this last part, and you're gonna need the time to do that. So I forgive the part 2, you can not do that. And you won't be counted, you won't be deducted any points for not turning it in. If you do turn it in, that's just extra. You won't get any extra points for turning it in. It's 250 points total for the paper and that, but my focus is more on the paper than the PowerPoint. So this part 1, you have to identify what fundamental differences exist between object-oriented, object-relational database systems and web-based. Don't half the time people forget the web-based one, so don't forget that. Tell me what the differences are between those 3 different database systems. And then you have to identify if those differences would impact your retail store. So just put a statement in there about would these differences between these 3 different impact your store in any way? If they don't, then you just state that they don't. But if they would, then you need to just tell me that they would and how. And they include details of what changes would need to be introduced to your database if it was used to build a data mart or data warehouse. And then also the same thing for what considerations would need to be made if you were to take your database and it were to become a distributed database system. What changes would you need? Just telling me that we would need to make changes to our database in order to meet these 2 doesn't fulfill that requirement. You have to tell me specifically what changes you would need. And then what specific types of business intelligence can be gathered from the database, might address that question. And then how would that information assist you in the decision-making process for your particular store? How would your retail store benefit from data warehousing in these following areas? Give me a return on investment. Provide a 3-year estimate. Just make up any numbers, I don't care. Just give me a 3-year estimate of that, your return on investment using business intelligence initiatives. How they would help you with giving you a competitive advantage based on your local market or increase productivity of your decision makers, right? Related to the business process decision making. And then there's 2 more sections here. How would you address the following data warehouse problems? Make sure you don't miss these. Required data was never captured. How are you going to address that issue? If there's a high demand for disk space and other resources, and then if there are hidden problems with the source systems that you weren't aware of, how would you address that? And then finally, of course, the final section is always in all of our papers, the analysis section. Don't forget to complete that as well. And of course, cite in text and references using APA format. In big red letters, highlighted yellow, you can skip this section. This is an augmentation PowerPoint slide. This part of the project I found to be extremely confusing for students and very difficult for them to try to complete. So I just allow you to skip it and focus mainly on your paper. And then that's it. You have my email address if you need me. Office hours or whenever you contact me, we can set up time, or you can go to my website and set up some one-on-one time if you need to. We won't have any more live chats. This is our last one for our class. So I appreciate you taking some time out of your evening and spending it with me here. Any questions or comments or concerns or help with anything you might need?
Um, Thank you very much, Dr. Conklin, for uh, um, so informative here. But the question I have was, you spoke more about relational type databases, and I know with all of social media and the copious amount of data that's generated, chats, uh, images, audio, all of that going towards big data and not being so relational as traditional models.
Right.
Is that, isn't that the trend that we're headed towards instead of relational? And what's your commentary on that,
Well, I guess it
please?
just depends on what the application is, right? Because where I work, we use nothing but relational databases. The system that I help support uses a relational database. All of the other systems that we work with use relational databases, but instances like Amazon doesn't use a relational database. Amazon uses a NoSQL database because of the fact that it captures data. It's a lot faster than a relational database in the way that it stores data, and it's able to capture all of that additional information, all those pictures for images, all the images they have of all the products they sell. Those things would not work well in a relational database. Right, they work better in the NoSQL database using Mongo. MongoDB is a NoSQL database. I taught a class on that here as well. So it just depends on the purpose, right? What type of database you're going to use, and there are several different relational database systems, right? Oracle has a relational database. Microsoft SQL Server is relational database. There's DB2 databases. There's NoSQL. There's MySQL, MySQL databases, which are used a lot with websites as well. Especially websites that are built
Oh,
using
never mind.
PHP, right? They use MySQL databases for their data store because it just works better with that programming language. So it just all really depends on the organization and the applications that they're using for what type of database they're going to use. But relational databases are still here. They're going to be around for a while. So hope that helped.
Oh, it did. Thank you
Good.
very much.
You're very welcome.
In our organization, we definitely use relational databases more, but
Right.
it's because they're tending or trending towards, being more interactive with users.
Yeah.
So we have to capture all those comments and images and audio and video
Yeah,
uh,
and other database
data. Yeah.
platforms are better suited to do those sort of things. So yeah, organizations are probably looking at those. Yeah, I'm sure
Mhm.
my company. I work for CVS Health. So I'm sure I know we use other database systems. We probably use a NoSQL database to capture information on prescriptions and all that good stuff. Um, but the function that I work in, we use relational databases, but I'm sure the company has other databases. I know we have data warehouses and data marts all over the place. I work with a couple of them, but I'm sure they have like a NoSQL database someplace that captures that data just because of the way it captures and whatever function they're going to use it for. Right? We do a lot of data analysis. Our informatics team does a lot of predictive modeling. And that sort of stuff. So they use the data in the data warehouse to do that, so they can, predict costs on medications and patient costs for healthcare and for insurance. So yeah, we use a wide variety of different tools, and it's fascinating. It really is.
And I'm sorry to hog up the time. I'm sure the
No,
others have
that's
their own
okay.
questions, but this one is more for the assignments. And so in
Yeah,
Unit 3,
yeah,
unfortunately, I decided on a very complex model, which I don't regret because I'm learning a lot in putting it all together. But
that's
I'm
good.
finding that Microsoft SQL Server does not allow the data to persist. So each time I come back and I have to repopulate my tables. Do you have any tips for that, or is that the expected behavior?
No, that's not the expected behavior. It shouldn't do that at all,
Okay.
unless you're running. If you continue to run the code that drops that, in the code that I provided on the first DDL statement at the top where it says use master.
Hmm.
If you're running that code every time, it's going to drop the database every time you run that code, which then drops all the tables, which then drops all the data that's in those tables. So then you have to recreate the tables and then repopulate them with data. But once you load them with data, if you don't drop them or delete from the table name or truncate those tables, that data will persist in that database table for as long. The system won't get rid of it automatically.
Okay. It shouldn't, and
Right.
maybe
It
I'm doing
shouldn't.
something wrong.
It
So,
shouldn't do it. The data should be in there. Once you load it, it'll stay there until you take it out.
okay.
Yeah.
That was my expectation, but I think
Right.
maybe I just skipped some tables and I thought I had data in there, but they came back up and they weren't deleted, but the table was empty.
Empty.
So I'll double check.
Okay. Yeah, make
Thank
sure you
you.
don't have any delete from statements where you're not using a where clause, right?
Yep.
Because if you do the delete statements that are part of the project, delete from orders, and you don't put
Yes.
a where order ID equals a number, you run that delete from, it's going to delete all
Delete
of the data.
everything.
Right.
Okay.
Yeah. So just check that.
I'll check.
Okay.
Thank you so much.
You're very welcome. David, Roland, do you have any questions or need anything, help with anything? Or are you guys good?
Sir, I have a question. What business intelligence tools would like to see in the paper? Is there something that you can recommend, or?
I don't have any preferences really for what type of tools there are so many different types of tools out there.
So just do research and then kind of
Yeah,
gear it
just
towards.
generalize it. I mean, you don't have to pick a specific tool if you don't want, right? Just generalize what you're going to do with those business intelligence tools. What sort of tools you would use. You can find one if you like. There's probably quite a few out there. I know I've worked in the past with one called there's one for data warehousing called Hadoop, which helps manage data in a data warehouse. And then there's one called Cognos BI. It's a tool for doing that sort of data visualization and data mining stuff, and it's pretty cool. That you can build data cubes with it. You can rotate the cubes and look at the data in different dimensions and stuff like we talked about. So either of those is good. Cognos is probably a good one. It's pretty much industry standard. It's used by a lot of organizations, but for data mining and stuff, you can download a free tool called R. It's a free software download. You can download data sample. They'll give you some data samples. You can download data sets and load it. And that tool does data mining and stuff. If you ever wanted to learn how to do that, you can play around in there. I do it every once in a while. I'll go in and run some queries and try to play around with it because it's different than a database, right? It's a different type of tool. So there's a little learning curve, but it's if you like doing that sort of stuff, it's fascinating. So whatever you can find is fine.
Thank you.
Mm-hmm.
I just wanted to thank you. I had issues with Unit 3 IP as well. But I just wanted to thank you so much for guiding me through that. I was having the same issues you were having, and he helped me through that. And I just want to say thank you, and I really appreciate it.
Not a problem. That's what I'm here for. If you guys always have the link to my website, and you always have my email address if you have questions on anything as you're continuing your studies. I'm more than willing to help if I can. If I know the subject and you have a question on it, or if you just need help with anything, just let me know. I'll be here for a while. My whole idea is that when I do retire from my full-time job, I want to go into teaching full-time. So anything, because I love teaching people things, I love helping. So if you ever need anything, even outside of this class, you have my website, you have my email address, feel free to contact me. You have my cell phone, you can text me or call me if you guys ever need anything. So just know that I'm here to help in any way that I can. And I appreciate all of you. You've done some really good work this term. It's a lot of work to cram in to 5 weeks. I know, especially with week 3, that's where people usually stumble because you're not used to working in databases and writing SQL code. So I try to make it as easy as possible. And hopefully some of the tips and stuff that I provided in the sample files will help for you all. So wish you best of luck as you continue your studies. And again, if you need anything, reach out, let me know, and I'm more than happy to help.
Thank you, sir.
Thank you all.
Thank you so much.
You're welcome. Have a good night.